Sensoc helps solar companies gather intelligence from their sites, and how they use drone technology to streamline various operations right from construction, pre-development through operations. And specifically, I'd like to show you how Sensor can help you get more business from the solar sector, and how we help drone companies such as yourselves gain a foothold in the renewable energy space. So that's what today's webinar is about. So to start with, I'd just like to give you an overview of SenseHawk and what we do. So SenseHawk is present in over 20 countries. So we are operating all across the globe, through the Americas, through Europe, Asia, Middle East, India, East Asia, and Australia as well. So we have presence everywhere. We work with drone operators in all these countries, and we have a large drone partner network existing drone partner network that we work with. And we're always looking for new drone partners to help us expand into new countries and also to help with our existing business. So we have supported over 200 gigawatts of solar and storage globally. And we have offices in 4 countries. So we have physical locations in the United States, in the Bay Area, and we have an office in Madrid. We have our office in Middle East office in Abu Dhabi. That is where I am, and that's where I'm presenting from currently. We also have a large R&D center in India. So we have presence across the globe, and we're helping customers not just in these locations, but in other locations as well. Um, and we are also backed by one of the largest corporate conglomerates in the world, Reliance Industries. We started our journey back in 2016. We were a typical software startup, and we were growing steadily. And in 2022, Reliance started developing a 100 gigawatt solar pipeline in India, and they decided to acquire us. So we are basically helping them manage their solar business as well. Right. So just to give you a very high level overview of what SenseHawk is. So we have what is known as a triple digital twin. So all of you might be familiar with what a digital twin is. A digital twin is nothing but a digital representation of a physical asset in a software, right? It can be anything. It can be like if let's say you're dealing with a solar plant in this case, right? So you can represent the physical solar plant in different ways. You can represent it on a map. So when you represent a solar plant on a map, you're essentially drawing the shapes and drawing the physical assets on a map, showing its locations. So that is what we call the map twin. So at the core of Sensor is a map layer. So we have we can take in your drone data, we can take in your the CAD files, which is the vector data, and show you a physical representation of the solar plant on our platform. We also have something known as the equipment twin. Now, if you look at the map, it is just a flat surface. It's a 2D representation, and the map does not know what is connected to what. So in a solar plant, you have a distinct hierarchy. You have connections between various components in a solar plant. So you have the solar panels, which are connected to an inverter, and the inverter is connected to a substation, and the substation is connected to a transformer, and the transformer is connected to your electricity grid. So on a map which just has shapes and images, you will not be able to make out what is what. So we also have what is known as an equipment twin, which establishes the connections between the various components in the solar plant. So it rests on top of the map twin, and basically, in essence, what it tells you is that if you go to a map in our platform, by the way, is called Task Mapper. I forgot to mention that. So I'll be using the word Task Mapper to refer to the software, and Sensoc is the name of the company that makes Task Mapper, right? So when you go to Task Mapper and you open a map and you click on any component on the map, what the equipment twin does is it tells you what that component is connected to, and it shows you all the connections. So it transforms a 2D representation into an intelligent system that shows you what all the components are doing with each other. Then the third is what we call the process twin. Now the process twin is, as the name suggests, you have a physical representation of the map, but you also want to know what work happens on the map. So, for example, during construction, you have a set of activities that need to happen for, let's say, the solar panels to be installed. First, you drive the piles into the ground. Once the piles are driven into the ground, you install the horizontal structures, and then once the horizontal structures are installed, you start placing the panels into the spaces available, and then your solar panels are installed. So you have a sequence of events that need to be followed. What our system does is it can also uh, replicate the sequence of events that need to be done to complete a particular process. So we have digitized essentially what we call it is a digital workflow. So, and the digital workflow lets you track all the work that happens on the site. And all of this together is what we call a triple digital twin. And this offers a complete solution to solar companies to track the work and what the kind of the progress of different activities and the current health of the plant and so on. So in a sense, this is what our platform is all about. So now, given that you have this context about what a platform is, I just like to instead of going into depth of all the features of a platform, which will take a lot much longer and is probably not something that is relevant to you right now. I just like to go into specific use cases where drones are involved and where our platform can use drone data to provide value to our solar clients. So the first is during peak pre-construction, right? So during pre-construction, typically, what does a solar company want to do? They want to assess. They're thinking of building, let's say, a 100 megawatt plant. A 100 megawatt plant will approximately require around 800 acres, or that's around 200 hectares of land. Now, even before they start the project, what the team wants to do is they want to go and assess the various land options that are there for them. So before they even start building the project or start getting financing for the project, they want to understand what are the land options. So when they're thinking of land options, they're looking at a bunch of things. One is, of course, the land has to be flat. It cannot have a lot of hilly areas. It cannot be a swamp. It can be a swamp, but then they will have to account for the cost of filling up the swamp with earth and making it flat. So all these various things. So first is to they assess the site for readiness for construction. They also have to assess its location on the map with respect to the nearest transmission line, because once you build a solar plant, you need to transmit the power to your customer. And so typically what they do is they shortlist like 5 or 6 different land parcels which are within the vicinity of where they want to send the power, and they then assess it. And typically, for the assessments, they do a very high. They don't do a very initially. They don't do a very high resolution drone survey. They do maybe at a 5 or 6 centimeter resolution drone survey, just to get an idea of what the land use is. They can potentially use satellite data as well for this, but obviously that depends on the satellite coverage and so on. And it's on-demand satellite data is not very prevalent everywhere. So they typically they do a drone survey at a very high resolution, I mean high GSD, to just get an idea of what is what. And then once they tick the checklist and say that this land parcel is fine, they then do a very detailed survey, detailed terrain survey of this land parcel, so that they can then send it to their design team, engineering team, to then do their initial design. So that survey is typically done at a much lower GSD, at around 3 centimeter RGB GSD. And they also do it with RTK and with using proper ground control, so they get a good 3D surface of the site. And how Sensoc helps is that in at every stage, both during the low GSD and the high GSD survey, our system allows the customer to take the drone imagery and put it on our platform. and they can start overlaying potential designs, and they can send it to their engineering team. The engineering team can then look at not just the visual maps, but also the contours and the z values of various locations on the site, and use that to come up with an initial preliminary design, is what they call it, right? So what our platform lets you do is both visualize the orthomosaic, the RGB orthomosaics, and it also lets you do elevation profile, cut and fill analysis, and so on directly on the platform, right? So this is how Task Mapper helps our customers during pre-construction. Now, during construction, now once the construction is started, our customers continue to use our platform for also detecting the earthwork. Now, earthwork is basically, like I said, when you first select the site, you try to make sure it's as flat as possible, as even as possible. And obviously, there might be some uh, slope changes that need to be accounted for. So for that, they do an earthwork process. That is before the actual piling and all the other cabling and all the electrical mechanical work starts. So for earthwork, what we do is our clients, they take a small section of the site and they fly it at a much. So earlier said that we do it at 3 centimeter GSD. For earthwork, they do it at an even lower GSD. They do it between 1 to 1.5 centimeter GSD RGB survey with with proper GCPs, proper control and RTK corrections. And this produces a very high resolution, very dense DSM and point cloud. And our system basically takes that and then it gives them it provides them the cut and fill requirements. Where does earth have to be removed and where it has to be placed? And we provide a file to our clients telling them that this is your pre-earthwork surface. And then after the earthwork is completed, they do a similar scan again. And then this time again, we do the same analysis and let them know whether the final surface that has been generated is as per the specifications of what they want to do or not. So essentially, this can be used. Essentially, we are helping them with daily cut fill analysis. Right. Now, this is something that is specific to certain geographies where we have. I'm talking about the SWPPP, which is stormwater prevention systems. So in many countries, you have very strict environmental requirements where during construction, any erosion that obviously you're doing a lot of earthwork while you're during construction. So you don't want any of this earthwork, any of this soil to run off during construction due to rain or any other weather event and cause pollution in the surrounding areas, right? And if in lot of places the government imposes very strict fines on the EPC and the owner of the project if they detect any sort of erosion happening on the site. So to prevent erosion from happening, a lot of these contractors and builders have to monitor SWPPP on a very regular basis. So this essentially involves two things. One is if you see here, you can see there's there's basically a black color fence over here that is called a SWIP fence. It's essentially like some plastic bags that are kept during stormwater. They're kept to line up the perimeter of the site and prevent any erosion, any stormwater that containing soil from exiting the construction area. The other important thing is to look at monitor the basins. Typically, you try to contain the stormwater erosion. You build basins within the construction area so that all the stormwater runs off into these basins and does not exit the site and does not cause flooding in the construction area as well. So two things that they need to do is monitor the perimeter for the SWIP fences and make sure there is no breach. this requires a corridor flight instead of a standard, orthomosaic generating flight. So here you just do a corridor flight along the fence, and you also monitor basins. So you do a high resolution flight of the basin areas and upload these images to our site, and we generate reports giving you the SWIP compliance. We can also help with HSE, is basically health and safety. Uh, uh, these are uh, these are again very it depends on case by case basis what each the HSE norms are in each project. We'll be able to monitor the laydown yards to make sure that the all the inventory is being placed in the right place. Machinery is following the correct protocols, and no health and safety norms are being broken. Right now, this is so what I've been showing you so far is more of a quantitative sort of analysis where we are measuring some quantitative aspect of the site. It could be earthwork, how much earthwork is happening. It's how what the contours of the site are, and so on. Now we look at the quantitative aspects. This is essentially once all the earthwork is done, you start the actual process of construction. And most solar plants are it's like a cookie cutter sort of operation, because if you see every section sort of repeats one after the other. It's you have one set of trackers, the same tracker keeps getting one set of solar panels, they just keep getting repeated one after the other across regions. So what a drones can help monitor the number of panels being installed, number of piles being installed, the number of kilometers of trenching that is being done, the length of cables that are being laid out. All of this can be easily detected aerially. So in the case of construction monitoring, typically what our clients do is they either every day or every week or once a month, depending on what their reporting requirements are, they fly a drone over areas of the site where construction has happened. Those images are then uploaded to our platform. We process it and we update the equipment twin that was that was talking to you about at the beginning of the presentation. We update all the components in the equipment twin with the current status of progress. So if you're looking at these individual rows of panels, we tell in each row how many panels have been installed. And for individual segments of trench, we update that segment of trench with how many kilometers of trenching has been completed, how much is pending, and so on. And all this data is then fed into a project management system. A project management system is nothing but a system that is used to track various activities, and each activity will have a start date and end date. And our drone data basically sends information to the project management system that is built into Task Mapper, and tells our clients, okay, these are the activities where progress has been made today. These are the activities where progress is pending, and also compare it against the deadlines, against each individual activity start date and end date, and tell you you're falling behind on trenching and you're ahead of the schedule on for panel installation or cabling or whatever. So basically we provide a streamlined method of telling our clients, okay, this is your this is something known as in the industry as an S curve. We basically provide an S curve which tells you that this blue line is what was planned and this green line is what your actual progress is for various activities. Right. So this is construction monitoring. And yeah, this, like I said, it happens either every day or every week or every month. And it requires a drone scan for the sections of site where the construction is happening. Now, this is something slightly different from what you've seen so far. This is not drone related, and I'm just giving this as an information to you to show you what our platform is capable of, so you get a complete picture of Task Mapper. So we also have a fully featured mobile app. And on the mobile app, you'll be able to see the maps, you'll be able to see the components, you'll be able to see the drone images, the drone orthomosaics, everything, right? So what we also have is, like I mentioned in the beginning, we have a process twin where we can create workflows on the map. So a typical workflow would be an inspection workflow where uh, the contractor has to go, once the construction is done, the contractor has to go and inspect every module or every fifth module which has been installed, depending on what is there in that contract. So we can automate this process by on the map itself creating tasks for the field engineer to go. The field engineer will be able to walk the site, be able to see their own location on the map twin, just like Google Maps. And then they'll go to each location, click on the task, take a photograph or complete a checklist or whatever the workflow tells them to do. And then it logs all the information, and any approvals gets routed to the respective manager, and then the final quality control report or the inspection report, it gets exported into our inbuilt file management system. So basically, if you see, what we've done is all the way from earthwork, which is the first step, through construction, which is the next step, and finally through QC and inspections, which is the final step of the construction process. We provide our clients with end-to-end solutions which help them track the work that is happening on the site. And everything happens on a map-based platform. And this is something else that we recently introduced. We also have an AI copilot in our platform where you can ask it questions, and it'll take the drone data or the map data, whatever it is, and give you information on what the current status is of construction progress, of NCRs, which is non-conformance reports, and so on. Now, this is another interesting thing, which I mean, which again is not drone related, but this is something that you can potentially offer to your clients. Now, once construction is complete, a lot of times the contractor, the person building the site, needs to provide an Excel file or a spreadsheet where these individual elements, these are called trackers, and this collection of trackers is called a block, inverter block, because you can see here there's one inverter over here, and this inverter is connected to all these trackers. Now, our contractor will be required to provide a Excel file which tells exactly the barcode of each module. So each tracker here has around 90 modules. So you'll have to tell tracker A contains modules 1 to 90, then this one has track modules 1 to 90, and so on. So you need to log the barcode of each and every module against each tracker, right? And this is typical. This is what we call barcode scanning. That is another app that we have. Now, what happens is that at the time of commissioning, that is the handover of the project, once construction is done, two or three engineers will have to walk the entire site, keep scanning the barcodes, and the barcodes get logged onto our system, and then it gets attached to the equipment twin that we spoke about earlier, and the final report is provided to the customer in a neatly formatted Excel file. Now, again, this is something that could potentially be outsourced, and if you have people who are available who can, in addition to flying drones, are also field personnel who can go and perform this barcode scanning, this is some value-added service that you can potentially provide to customers, to your solar customers, for whom you're also providing drone-based services. Now, this is the final step of the solar life cycle. So once construction is done, commissioning is done. Now the plant is connected to the grid. The contractor has left the site, and the owner of the site has now deployed their field people, what we call O&M, which is operations and maintenance people, to start maintaining the site. Basically, now that the site is built, you need to make sure that nothing goes wrong on the site, everything is functioning properly, and you're maintaining the site as per to for top condition and top performance. So at this stage, again, we help our clients. Here, um, as you know, basically a solar plant functions by converting solar energy into electrical energy by through the properties of the solar panels, right? Through the um, so if a solar panel is not producing energy properly, if there's for any reason there is say a defect, there is a one portion of the panel is damaged, or there's some electrical problem, and the panel is not connected, there are two types of things that can happen. One is the resistance in the panel increases, and that causes the panel to heat up. It's something called as I squared R losses, and these I squared R losses cause portions of the solar panels to heat up. You can see them very distinct heat signatures. The other thing is if a panel is not producing energy, then the solar and is just disconnected and sitting on the side, the solar energy that is incident on it gets reflected, and it again causes the solar panels to heat up. So in either case, you'll be able to notice that there's something wrong with the solar panel or with a portion of a bunch of solar panels, or with you can also look at the RGB images which are collected along with the thermal sensor to look at what the possible cause of these defects are. So if you see some portion of the thermal orthomosaic heating up, you can then quickly check on the RGB orthomosaic whether there's a dirt, or there's some damage, or there's some sort of shading that is causing the defect to happen. So essentially, what we do is send a drone pilot to the site, collect both RGB and thermal imagery. The thermal imagery needs to be I mean, there are two standards typically that we work with. One is the IEC standard, which is the most rigorous standard that needs to be followed. And for that, we need to fly the thermal sensor at 3 centimeter GSD. And depending on the sensor, uh, we- it uh, it would require us to fly at maybe 30 to 40 meters above the panel surface. And in other sites where IEC standard is not required, IEC is a standards organization. In some cases, the IEC standard is not required. In there, you can just fly it at 6 centimeter GSD, and you still be able to capture most of these defects, right? So this is another major use case, obviously, of drone-based inspections. Um, So as I mentioned, yeah, so these are IEC spec. This is the spec that is followed for drone thermography on solar sites. And they have different types, different levels of defects based on the severity. And we also have different categorizations of the defect based on the thermal signature that we see. Here, for example, the string is hot, where string is basically a collection of modules which are connected in series. And basically, if a string is hot, that means the string is in open circuit. And the module could be hot, in which case the module is in open circuit, is not connected. And you can also look at visual indicators where the tracker is. So trackers are they have a motor which tilts the angle of the panel so that it's facing the sun at every point of day. If the tracker is malfunctioning, you can see over here that it's clearly not, there's a problem. So, what do we offer? We offer let me see if I, and we also have support for thin film, which is a different type of PV modules. It's not very important for this presentation. So, yeah, so how does this work again using our platform? So, the client will request for a drone thermography survey. These typically happen once in 6 months or once in 12 months for a plant that's in operation. And the drone team goes to the site. They start collecting data, and depending on whether they're collecting data at IEC or at the 6 centimeter GSD that I spoke about, you'll have different rates at which you're collecting data. So at IEC, with IEC specs, you'll typically collect data for around 20 megawatts to 30 megawatts a day per drone. So you could have multiple pilots in case you want to cover larger areas in a given day. And at the end of the day, that information is that all those images are uploaded to the Task Mapper platform. And then we process the platform, process those images and create the IR orthomosaics. And then we run an AI-based detection algorithm, which automatically detects and classifies the various anomalies that are found on the orthomosaic. And then then those reports are then presented on our TaskMapper platform, where you have the orthomosaic and you also have these workflow tasks that I spoke about earlier. The same inspection task can be modified, can be that is used during construction can be modified to work during operations as well. And so the your customer, that is the solar asset management personnel, they will receive alerts on their mobile saying that, okay, in this particular section these defects have been found, go and fix them. So they'll take their mobile app, go to the site. They'll be able to navigate to the exact location. They'll also have the thermal images that were collected during inspection attached to these individual map based work orders. They'll be able to then complete that checklist, and they'll be able to complete the uh, they'll be able to complete the remediation process at the end of it. Right. So yes, so this was basically the last step of the asset life cycle. So we have covered everything from pre-development through construction through operations, and we have looked at how drones can help at every stage, and how TaskMapper specifically will help streamline your drone operations as well. We'll be able to deliver complete closed loop workflows where the data is collected from the site, it's uploaded into our platform, it is transformed into actionable uh, actionable work orders and tickets on our platform that can then be acted upon by people using our mobile app. So so this is basically what I wanted to present. Now I guess uh, Dania, we can take questions, but before that, we can then do the third poll that I spoke about, because I think we have given a good overview of everything, and we can look at what they would like to. In case we have time, we can also do a short demonstration of specific use cases, and we can also take questions for the rest of the time we have.
Okay. Thank you very much, Karthik, for your presentation. Meanwhile, I'll create the last poll. Maybe you can start with a short demo. Meanwhile, I'll do the poll. I don't know how many time you will need for the demo, because I think that the demo will be very interesting. If you're gonna present the thermal.
Sure.
Okay, great.
We'll
And
do
I can send the last question.
Sure.
Meanwhile.
Let me just open up the demo.
Great.
Okay, is my screen visible? Yeah. There we go.
Yes, we can. Yeah.
Right. So again, this is the Task Mapper platform, and what you or your clients will see as soon as you log in is a list of all the assets that are or projects that you're working on. Like I said, we can have projects at different stages of the life cycle. The first thing that I show is O&M, because I think that is something that uh, will be very relevant to a lot of you. It's something that you can very quickly start working on with your clients. Right. Right. So as you can see at the top, there are different software modules. We have tasks, forms, and files as well. But the relevant module for drone inspection would be the maps module. And we'll go to the thermography section to give you an overview of what the thermography looks like. So you can see over here, you can select the various scan dates if you have multiple scans, you'll see all the different scans for this particular section of the solar site. And you can select multiple blocks or areas within the map over here. If you zoom in, you can see the actual thermal orthomosaic, and you have these different defect types on the left. So I'm just going to um, click on a particular defect to see its details. So here you can see there's a telltale line running uh, across the top of the module. This is known as a bypass diode active. Essentially, each module consists of rows of cells which are connected in series. So if there's something wrong with this row of solar cells, the bypass diode becomes active and this section gets heated up. So our platform is able to detect this pattern and automatically lo- classify the defect. And also it knows which inverter the defect is located on. It's also has the exact location, block, section, and the tracker. So this is basically the nomenclature used by our clients. And you also have a delta T, which talks about what the difference between the heated part and the unheated part of the module is. Here you have the module serial number, which I spoke to you about. If you have already done a barcode scan, the exact module serial number will show up over here. So you'll be able to use it for warranty and other purposes. And then you can see here, these are the raw images which were actually flown and used to stitch you can see the bypass diode is active over here. And it's not just for information. You can see over here that this defect essentially acts like a ticket for your customer. So you have the status over here. You can go from pending, verified, in progress. So once the scan is done, you can assign this defect to different people in the client team, and they'll be able to prioritize it as critical, high, medium, low. They'll be able to uh, resolve it, and they can also create a task, which is basically it opens up a task in our task management system, which is not used just for thermal. It can be used for other ticketing tasks as well. But essentially, you'll be able to connect your thermography findings with the other modules which are there in our platform, right? And like I said, if you use a mobile app, the same whatever you see over here will show up on the mobile app. The obviously the additional thing is that your location shows up like a blue dot. You'll be able to navigate to the exact location of the site. On the site, you'll be able to click on it, take images, attach it to the defect, and to perform remediation, right? And this is a report that your client will see, which will show you what's the affected capacity, the number of affected modules. They'll be able to see statistics of what the defect types were across the platform, what the current remediation status is, and so on. And you can also go to the defects page and can select one or more defects, and you'll be able to export as Excel or export as PDF to generate reports, right? And I'll quickly move to the construction side as well, because that's the other important thing. Now, I just want to show you a very high level of what your clients will see. So you can see this is a proper project management dashboard. They're able to see all details about their plant. They're able to see the roads constructed, fences installed, so on. All this information, and they're able to get an idea of what the current work is, what the cumulative work is, and so on. So all this information is being the basic source of all this information is the drone map. They're using the drone. We are using the drone maps to detect how many meters of road is constructed, how many meters of fences are installed, piles are installed, modules installed, and so on. So I just show you the map itself to give you an idea of how that works. So before that, I'll just show you I mean, we started the presentation with our equipment twin and process twin. So I just wanted to show you how that pans out. So the first step is to create the map twin, where we take essentially we are taking a CAD file, the AutoCAD files or AutoCAD civil file, which is generated by the engineering team of our clients. And we typically divide it into civil, electrical, and mechanical, depending on the type of work that is being done in each case during construction. And then if you click on here, I've selected a tracker, which is basically a mechanical component. If I click on view details, I'm able to see all the information about the tracker. So it's not just a map element; it also has information about what the tracker is, what type of all the specifications and warranty documents and everything. And you also can see the hierarchy, which basically tells me, okay, this tracker is connected to this DC disconnect is basically like an electrical component. It's connected to this substation, is connected to it's in the solar farm. So you can see the full component hierarchy in the using the equipment twin. So this is something that establishes the relationship between the various components on the map. This is not very important for you. I'm just giving it to you for information. The most important part is obviously the drone related section. So this is how our platform works with drone maps. You can see here there's um, the RGB orthomosaic at the back, and then you have the same components that I spoke to you about. Depending on what the current status is of this section of the map, the color of the component is updated. So to understand what these colors mean, you look at classes over here, and you can see we are dealing with trackers. So on the tracker progress, you have not started, pre-drill, complete. So this is the third step of construction. And this has essentially reached the pre-drill complete stage. Now, if you look at another section of the map, let me do a later scan. So here you can see this modules installed has been updated. So modules installed is the eighth step in the process, right? So you can clearly see that all these modules have been installed. And yeah, the other color codes basically this is the tracker installed, the modules are yet to be installed. So our platform essentially takes this orthomosaic and it classifies each individual component based on what the current status of the installation is. And then, so sorry, Danya, you raised your hand.
Yes, just to let you know that the poll is ready, so I can launch it.
Okay. The poll is ready. I'll
And we
just
have
complete
7 minutes.
this small
Okay, great.
section. Yeah. So just to complete the loop. So the map that you saw is then connected to our project management section, which is essentially if you're familiar with Microsoft projects or Primavera P6, if not, it's essentially a Gantt chart where you have various activities of construction. And if you see over here, we have construction over here, different aspects of construction. Now, we earlier saw that there were some trackers where pre-drill was complete. Now, if I look at the view details, you can see that this activity is being updated. And how is this activity being updated? This particular activity in the project management is the schedule is taking it from the maps. It's taking from maps from the from a particular map within skid 23, which because this is related to skid 23, and it's taking a certain activity which is being updated over there. So as and when a new drone map comes in, the progress gets updated there, and then it gets updated in our project management schedule. So uh, essentially the project manager and the planning engineers, they're able to just using a drone map, they're able to directly get an updated schedule with the current status of the progress. All right. So this is a last uh, poll that we have. I mean, I just want to understand what your interests are based on what we have shown you so far. Um, Let me just stop. We went through the entire solar life cycle, right from pre-construction through O&M, and also I showed you some standalone tools which don't exactly work with drone data, but still will help your clients. So I just want to understand what is the most important, most interesting for you,
Well,
and also I'm ready to take any questions that the audience might have.
well, I might update you, Kartik, that until this moment, the thermal inspection and AI power is been the most.
Is the most important.
Yeah,
Yes.
yeah, yeah, yeah. Followed
Yeah,
by
that is the easiest to
yeah.
also get in because it's a point solution. It's not like it happens once a year, so you can or once in 6 months, so you can just step in and start doing the work, and it's something that I think it'll be easy for our partners here to also start working on.
Can you let us know which country are you actually having projects?
So I mean, it'll
The region.
easily hit 100, I think. Like we need to. So in Africa alone, we work in South Africa. We work in Nigeria and Kenya. We work in North Africa as well. Um, uh, where is the Quilamba project, Manu? Which country is it in?
Angola. We have in Angola.
Angola. Right, right. So we have a construction project as well in Angola that is happening live. So we are working all over Africa. In South America, we work in Chile, in Brazil, in Chile and Brazil have been the main countries in South America. Central America, we have a lot of projects in Mexico, and the US. Obviously, we do a lot of work. Australia is a big market for us. We work all over Europe, so we are basically spread out all across the globe in terms of our client distribution.
Interesting. Thank you very much. Well, yeah, the tendency is like the thermal inspection and AI power.
Perfect. So, I mean, I'll be happy to help any of your partners in any way with it can. So we have I have Shikhar and Nitesh PV on the call. They directly work with our drone partners across the world, and they'll be very interested in understanding how we can help you. And similarly, if you have existing clients, how we can help them. It's something that we can always coordinate on once the webinar is done.
Great. Excellent. Excellent. Any other question from the Flying Labs? Well, if not, this webinar has been recorded. We will share it with the whole network. Thank you, Kartik and SenseHawk team for sharing with us this interesting solution. We understand you have more than the thermal solution, that you have the pre-construction and construction is mainly a workflow. Thank you very much. I'm pretty sure that after we share the recording, some other question might arise. So we'll be happy
Sure,
to
we are.
contact you.
And please feel free to share my email with anyone in your network. I'll be happy to speak with them, clarify anything.